Hey, this is Mike from Minimal 3DP, and today I'm continuing my series on using the calibration tools in OrcaSlicer. And today we're covering Max Volumetric Flow. So let's go ahead and get started. Now, as we noted in our last video, we're working our way through all the different calibrations listed in the calibration menu for OrcaSlicer. As you can see, I just finished the temperature tower. We're now going to calculate the max flow rate. So let's talk about what that is for a second, and then we'll switch over to the test. Now, max volumetric speed can be defined as how much filament your your nozzle can push out at a given speed and temperature. Now, it's important to understand that when we change materials, we change extruder, we change the nozzle, we are in fact changing the volumetric speed. Now, as is noted here, the brand types and even color types can affect the flow rate. Now, in my case, I don't really think it's making that big of a difference. So I'm just going to do one max flow rate for PLA, one for PETG. And if I have to later on, I'll make some adjustments. Now, if we want to increase the speed and flow, we also need to increase the temperature. Right now, we've already set the ideal temperature. I ran that last video. I'll link it above. So basically, we're going to run this. It's going to run a serpentine pattern. And we're going to look at the serpentine pattern, and we're going to look for where the layers start to delaminate. Now, a good indication of where they start to delaminate is if we see a change in surface finish. Now, this is a little bit more fun because I am using a tricolor silk PLA for these tests, because my goal is to use the Sovol, since it's an open printer, for PLA and models I'm going to give and print in place that I can give to kids at STEM events. So they do recommend you start with the default settings. And so we'll do that. So let's go back over to OrcaSlicer. I'm going to go up to calibration, max flow rate. And this is starting speed at 5 and volumetric speed is 20. I'm going to up that to 40 simply because I know that the Micro Swiss Flow Tech is rated much higher. I'm going to change this to 10 because I know that's lower than the rated volume. The step is 0.5. Let's hit OK. I'm going to discard my settings. And you can see this has generated the serpentine pattern. A couple things will change here. I'm going to hit auto, so that way we get a bit of a brim. Let's just slice this and take a quick look at how this is going to come out. So it's hollow. We have a brim. I'm going to go over here and look at flow. And you can sort of see how this is ramping up. And so again, pretty interesting stuff where it starts down here. If we look really closely at these blue temperatures, or I'm sorry, blue flows, and then goes up into goes on up from there. Now, I think in my case, let me go back. And I want to change that back to 5 to 30 to 35. I think that looks a little tall to me. So let's change this to 5. And I'm going to go to 35 here. That's still tall. I guess I really didn't change anything since I bumped the bottom number 5, but that's fine. I still want this on auto. I'm going to hit yes. Let's hit slice plate. And let's send this to the printer, and then we'll try to diagnose it. Now, this does give me more of a change here at the bottom, so that's good. Let's hit print, and they should send to the Sovol, and we'll come back and take a look at it. So as you can see, the model has finished printing. And just looking at this, it actually looks pretty good up until about this area here. And there's some deformation pretty much going all the way around the model. So really, this should be real easy to measure. So let me take it off the bed and I'll move it over to my desk and we'll measure things out. So I'm taking my calipers. I'm going to apologize. I don't think it's a battery. The screen on this is a little wonky, so it's sometimes hard to see. I'm basically going to start from the bottom of the model. And I'm going up to right about where the deformation starts. And I think that's 48.69. 48.69. So let me write that down and then we'll do the math. So if you go over to my website, I have my calculator hub, and right here I have Max Volumetric Speed. Now I know I could memorize these equations, but I constantly forget them. So I'm just going to open the calculator up, click on calibration. And so I started at 5. The step value was 0.5 and the measure distance was 48.69. And I'll go ahead and put in my 210 here. Hit calculate limits. Now, according to the documentation, you probably want to do something like 5% less than what this max value is, 5 to 10% less. And I'm going to basically take the 5% value. I'm just going to copy the clipboard and then go over to my slicer and we'll add that in. So let me switch over and we'll take a look. So I'm back in OrcaSlicer. I'm going to go right up here to my silk PLA that I'm working on, hit edit. I'm going to scroll down here to the bottom and then I'll paste that in. Now, just to be on the safe side, I'll just go with 27. That should be fine. And I'm going to save the filament. So now I have the max volumetric speed. So as I mentioned, I am working my way down the list here of calibrations. And the next thing that is recommended by OrcaSlicer is pressure advance. Let's go over and just take a quick look at the calibration guide. So with the max volumetric speed set, the next test will be pressure advance, and then also I'm probably going to cover adaptive pressure advance as well. Now I should mention when I do this calibration, I'm going to show all 3 different methods, and then you can choose the method that works best for you. I believe that the ideal method, according to everything I've read, is to use the pattern method, but I'll show you all of them just so you know how to use them and diagnose things. So with that being said, I'll look forward to talking to you again soon. If you have any questions or comments regarding max volumetric speed, please post them below in the comments and I'll get back to you as soon as I can. Thanks. Have a good day.